Real or non-real? Non-real. Now it's still plus or minus, so you still have two solutions, but they are non-real solutions. And so rational or irrational doesn't apply. Just two non-real solutions. So this is the beginning of the fourth video. That's what we're starting now. Okay. All right. Okay. You too. All right, so let's look at some examples. Put one here on this page, and then we can do three more, as many as we need before we go. So the first example, we'll do 1 minus 2x equals 4x squared. So first, put it in standard form. There's no fractions, so just put it in standard form. Now note, just like where we started, if you want your quadratic to be positive, okay, it's generally cleaner. It's not as important for quadratic formula, but just to be consistent. So since it's already positive, move everything else over to be with it. Okay. So 4x squared, and then I'm going to do everything in the correct order too. So plus 2x, and then minus 1 equals 0. And I also just went ahead and flipped it over. Okay. Now that's not factorable, but you can check your ACB and see if it is. But it's not. Okay. So we're going to go ahead, note your A, B, and C. So A, B, C, and also then find your D. Okay. I'm going to go off to the side, find my D. My D is just first I have to find my A, B, and C. So my A is 4, B is 2. Be real careful with the positives and negatives. Okay. And so my D, I always put my B squared in parentheses. Okay, so I got B squared, but because if B is negative, of course, even if B is negative, that's going to become positive. Either way, the square makes that positive. This is going to be a positive number because it's being squared. So be careful if you put in the calculator. If B is negative and put in the calculator without parentheses, then you'll get the wrong answer. Okay? So just for consistency, parenthesis, your B square minus 4 times my A times my C. And that is a first little calculator step. Okay? So we got 2 squared minus 4 times my A, which is 4, times my C, which is negative 1. There's my discriminant. It's positive 20. Okay? So, what is the nature of my solutions I'm about to get? Are they going to be real solutions with a positive 20? D is positive. Radicand is positive. Real or non-real? Real. Perfect square or not? No, not a perfect square. So they will be real because it's positive, and you will have 2 of them because it's not 0. But it'll be 2 real irrational solutions. You're going to have some radical left in it. Okay? So now I'm set up to use my quadratic formula, which is already solved for x. I just have to crunch my numbers. Now the formula, the last step here after you find the discriminant, my goodness, is, I was like, where did I put it? The last step here is use the quadratic formula. Okay. And the quadratic formula is, let me write it over here so there's plenty of room. So it is x equals negative b. The formula says negative b, so if your b is positive, then that would be this would be negative 2. But if your b is negative, then it's negative your negative b, which makes it positive. That negative is part of the formula. It's going to flip the sign of your b. Be real careful about that. Then plus or minus square root of your discriminant, which is b squared minus 4ac, but it's easier to look at the formulas if you think of it this way. Negative b plus or minus square root of d. You already calculated your d. Okay. And over 2 times your a. So I'm solved for x. My b is positive 2, so the formula says negative b, so negative 2 plus or minus square root of my discriminant, which is 20, over 2 times my a, which is 4. You're solved. That solves it. And you know from finding your discriminant that you know you're expecting 2 real irrational solutions. Your job now is to simplify. So I have negative 2 plus or minus square root of 20. Simplify your radical as much as possible. So that would be 4 times 5, so it's 2 square root of 5 over 8. Now, this is a case of, you look at that two-headed fraction. If you were simplifying one fraction, you just have to find a number that would divide into the numerator and the denominator. Well, a GCF of the numerator and denominator to divide it down and reduce it. Here we've got a two-headed fraction, so we need a GCF of 3 numbers. What's the biggest possible number that will go into all 3? 2, 2, and 8. 2. So it's like reducing a fraction, but it's got 2 numerators. So we divide this by 2, this by 2, and this by 2. Sometimes there's a bigger number that will work for 2 of the numbers. It has to be the GCF of all 3, or it's not fair. Okay? So you're dividing that by 2, and that by 2. So that equals negative 1 plus or minus 1 square root of 5, so just square root of 5 over 4. Okay? You divide that by 2, divide that by 2, divide that by 2. Okay? So your solution is negative 1 minus radical 5 over 4, negative 1 plus radical 5 over 4. So I use this as a two-step formula. If you've used this before, you might have used it as one, and I think that formula can be kind of big and intimidating. 2 steps because it breaks it down to help you memorize it, and also that first step not only gives you that number, which is going to simplify the next step, but that number is going to tell you what to expect. Here's my 2 real, no I's, irrational solutions. They still have radicals in them. And of course there's 2 of them because one was plus, one was minus. Make sense? Okay, so we'll finish up some other varieties of things you'll see. Now if you put this in the calculator, you would have a parabola that went through 2 x-intercepts. Okay. X-intercept, x-intercept. Okay. And they, even though those are ugly, if you put negative 1 minus square root of 5 divided by 4 in your calculator, it's going to give you a number. It's an irrational number, so you have to approximate it to graph it, but that will be a place on the x-axis, like we saw at the beginning. So let's do 4x squared plus 5x plus 2 equals 0. 4x squared plus 5x plus 2 equals 0. That one's already in standard form. Just check, no fractions. So I'll find my A, B, C, and my capital D. My discriminant, b squared minus 4ac. Now here in this one, let me make a note of this. We know just by looking at that, because d is greater than 0 and not a perfect square, we know we're expecting 2 real, irrational solutions. Oh, no, go ahead.
So on this method, when you moved it over, you got to change the signs on the all of it? Because how I'm used to, when you move it, that 4 to the other side.
Oh, okay.
I will take it to, it should be negative 4x squared, right?
Right. It would be negative 4x squared minus 2x plus 1. My habit is I always want to think that quadratic is positive. So since it was already positive, I left it there, and I moved these things over to join it. So that made it a plus 2x and a minus 1.
Right.
And then I just flipped it over because I prefer to look at it that way. Yeah.
I was like that.
Yeah. It's just because my instinct is to keep that quadratic positive. Yeah.
I thought you had moved it.
Oh, yeah. You can move it either way, but then you'd have, if it's a negative quadratic, a lot of times you then have to multiply everything by -1, so it's just an extra step. Okay. So with that negative discriminant, the negative d, what does that tell us about the solutions? Real or non-real? A negative radicand. Non-real. Negative D is the radicand, and if it's negative, that means it's non-real. Now, it is there, it's not 0, so you will have two solutions, a 1 plus, 1 minus, but they will be non-real. And of course, non-real numbers don't have rational irrational, so it's just two non-real solutions. Okay, so you're expecting an I. Two solutions with I's. So, we already solved for x. -5, negative b, so negative and then our b, so it basically flips the sign of our b, plus or minus radical square root of -7, or square root of d, over 2a. Okay. So you're solved, you just have to simplify, you just have to crunch your numbers. So first you're going to deal with the radical. First, you have to with the radicand, simplify as much as possible, and then you see if you can reduce the two-headed fraction. Okay. That's as far as we can go with the radical. Got to pull out the I, but then everything else is left over. And I look at my two-headed fraction. I got a -5, I got a 1. The I and the radical don't count. We're looking at just the numbers. There's a coefficient of 1 here, so -5. 1 and 8. Is there a GCF for those three numbers? -5, 1, and 8? No. So there's nothing to simplify. You're done. There's your two non-real solutions. -5 minus I radical 7 over 8, and -5 plus I square root of 7 over 8. Now, if you put this in the calculator, instead of equal to 0, we're going to call that y, because when y equals 0, that's the whole reason that x is your x-intercepts. If I go to y equals, this is actually the first one this is the first example we just did. But from the first example we did, yeah, there we go. So the first example we did, you have to put it in, oh no, that's a completely, okay, no, brain fart, sorry. Okay, so let's put this one in, so let me clear that. So 4x squared plus 5x plus 2. In order to graph it, it has to be in standard form, because that means that y is equal to 0, and that is the definition of an x-intercept. Okay? So that's going to give you a parabola with these x-intercepts. Okay? Now, because these were imaginary, if these were, the first one we had rational, right? We had irrational. We had two real answers. They were irrational, but they were real. So we had a parabola that's going to come down across the x-axis and then come back up, cross it again. We have two non-real solutions here. So how many x-intercepts do we have? Well, we got two solutions. We have two solutions for our first example and two solutions for this example. We have two solutions. But only real solutions are x-intercepts. If I graph this, let me zoom in there, because that's really close to the x-axis. There we go. Okay. So this is a graph of this parabola. Does it cross the x-axis? Doesn't even touch it. You have two non-real solutions. Only real solutions are also x-intercepts. Non-real solutions give you a parabola. They have you two solutions, and they mean something, but it does not mean where your parabola is hovering above the x-axis. Huh? The breakdown, and I'll scan this in with our notes, the breakdown looks like this. And then we'll go an example in the time we have left. If you've got a positive d, that means you have two real solutions. They may be rational, they may be irrational, but they're two real solutions if you have a positive discriminant, a positive radicand. So you're going to have a parabola that has two, so your two real solutions give you your two x-intercepts of your related graph. Now, if d equals 0, As we point out, you have one real solution. And that gives you kind of a parabola that hits the x-axis and turns back around. So it only has one x-intercept. If you have d is less than 0, that means you have a negative radicand and you have two non-real solutions. Then you do have two solutions, but they are not x-intercepts. You have a parabola that has hovering above, or if it's inverted, hovering below the x-axis. It doesn't touch the x-axis. So that's why it's important, especially moving into college algebra, you understand what that discriminant means, and these are three possibilities, three variations of what parabolas can look like. Crossing the x-axis twice, hitting the x-axis and turning around, or hovering above or below the x-axis. Okay. See if we can get one more solution. I'll scan that in too so you can sort of look at that. That's the bigger concept I want you to get before we go. That's going to carry you into college algebra. Okay. So let's do, here's one with fractions. 2/5 x squared minus 1/5 x minus 3/5 equals 0. And I'm also going to put one more up here. So whatever time we have left, we can work through these. So 4x squared plus 9 equals 12x. Okay. So the first step is to kill fraction, put it in standard form and kill fractions. Remember, it doesn't matter if a doesn't have to equal 1 or anything like that, but you don't want your a, b, and c to be fractions. So multiply everything by the LCD over 1. The LCD in this case is, of course, 5. So everything gets multiplied by 5 over 1. So this is times 5 over 1. This is times 5 over 1. This is times 5 over 1. This is times 5. Still, it's still 0, though. Now that, of course, leaves you with 2x squared minus x minus 3. 1x minus 1x minus 3 equals 0. Standard form, fill in the fractions. Now you know your a, b, and c. You do not know your a, b, c until you clean it up like that. Standard form and kill the fractions. Now, be real careful here because your discriminant is b squared minus 4a. So if our b is negative 1, we are squaring a negative 1, which is going to make it positive. If you enter this in the calculator, but you put in negative 1 and don't put it in parentheses, you will get the wrong answer. Negative 1 squared could be positive 1 or negative 1, depending on whether you use parentheses or not. And if you don't know what I'm talking about, that's a basic exponent rule. Talk to me after class. We've got to clear that up. Times a times c. So, which is time, bless you. When you plug that in your calculator, just to emphasize, got it. Parenthesis, negative 1 squared minus 4 times a, which is 2, times c, which is negative 3. That's 25. Oh, so there we go. Negative 1 in parentheses, minus 4ac. So we've got a positive discriminant, and what else do we know about it? Is it a perfect square or non-perfect square? Perfect square. So it's there, it's not 0, so we're going to have two solutions. It's positive, so they're going to be real or non-real? Real. And are they going to be rational or irrational? Will there be any radical left when we're done with it? No, because it's a perfect square, so they're going to be two rational solutions. When you have two real rational solutions, what this means is you could have factored it. Okay? I mean, at this point, go ahead and just use the quadratic formula, but you could have factored this. That's factorable. Okay. It's a not equal to 1, so you have to ACB it and then group it. Okay. But this tells you if they're rational, that means there's no more radical sign, you could have factored it. But we're going to move ahead. X equals negative b, which means we write what? Do we write negative 1? Yeah. And I'll just write out the formula. This is negative from the formula, and our b is negative 1, so it's negative, negative 1, which will make it positive. Plus or minus radical 25 over 2 times 2. And now we just simplify. Negative b is negative times negative 1, so it's a positive, flips the sign of b, plus or minus radical 25, which is just 5, simplify the radical, over 4. There's our two real and rational solutions. No more radical sign. Now this is two answers. One of the answers is 1 minus 5 over 4. And the other answer is 1 plus 5 over 4. Okay. But you can simplify them further. Combine the numerators, put them in lowest terms. This is equal to negative 4 over 4 and 6 over 4. Or in other words, negative 1 and 3 halves. Do you feel confident enough? I know it's a little rushed at the end. Do you feel confident enough to attack it now? Does it seem broken down enough that the steps make sense? Okay. When we put on the study guide there, steps in that order will walk you through any of these problems. This last example we didn't get to, I'll just point out that when you put this in standard form, 4x squared minus 12x plus 9 equals 0, and you find your A, B, C, D, A is 4, B is negative 12, and C is 9. And then your D, when you calculate that, your discriminant is going to be 0. And your D, very careful, that means your D is negative 12, put it in parentheses, squared, minus 4 times your A times your C, and that's going to equal 0. And so when you solve this, you've got x equals negative B, which is negative negative 12, plus or minus square root of 0 over 2 times 4. Same formula, but because that D was 0, you were expecting one solution, and it will be real, and it will be rational. I'm going to abbreviate rational solution. And this means the related parabola would hit the x-axis and turn around. And if this happens, that means you had a perfect square trinomial here. This is actually 2x minus 3 squared. 2x minus 3 times 2x minus 3, because it's a perfect square trinomial. Which means, yeah, you're expecting two solutions, but it's just a double or repeated solution. Perfect square trinomial, binomial squared, a double or repeated solution. So at that point, you can say, oh, perfect square. Okay? Or if you continue on, you would get positive 12 plus or minus 0, so you don't have to write it, over 8, or 3 halves. A single solution, the vertex of your parabola would hit the x-axis at 1.5 at 3 halves, and then turn back around. Have a great Thanksgiving, great holiday. I'm available via email. I'm going to be in the lab in about 10 minutes. I will be in the lab Monday morning from 9:30 to 10:30. I'm available for appointments on Monday afternoon. Let me know what you need via email, either questions on email or to set up an appointment with me. Come to the labs. But enjoy yourself and look for those solutions to the practice test to post. So you can be studied and ready for Tuesday.
When are you going to post this?
Sometime this weekend. I'll get it done as soon as I can. I rewrote this practice test, so I have to redo all the solutions too. So sometimes I use ones I used in the past, but this one needs a brand new solution set created. So. But I'll send out an email once I post it, so I'll let you know when all that updates. I'll get all these notes scanned in and posted before I leave today. And the videos.
Empezaste ese Thanksgiving intentando. Yes. I'm going to go back to work.
I'm sorry? Okay.
I'm planning a last minute trip this weekend.
Okay.
I'm leaving Friday, and I should be coming back Monday night.
Okay.
So I'm just scared I won't be here for the test in the morning. So
Oh, okay. Will you be? Are you going to have access to email? Will you be able to let me know as soon as you know?
yeah.
Okay. And have you taken? Have you used the testing center yet? I mean, have you
No,
taken a
I've
makeup?
never-
Okay, because you're allowed one free, no questions asked makeup.
Yeah, I've never taken it.
Okay.
Ever.
Yeah.
So,
So
I
if
don't
you-
know how that works.
Okay.
That's what-
So if it looks like you're not going to make it, just email me as soon as you know.
Okay.
Okay. What is going to happen is if you're not